Any sheets to turn in? Nobody did that. Nah, you're just hanging back. You're not going to do that. That's fine. That's okay. All right. I'll wait just a minute, but then I want to get started, so and they can just come up and sign it. That's okay. And we'll have a break. I mean, not a break. We'll take a break at the hour, but we'll also, there are a lot of exercises. We can have an announcement that they can sign in there. Okay. All right. It's 1:30. My name's Michael Saylor. I teach in the College of Engineering. My background is have a BS in Applied Physics and a Master of Science in Electrical Engineering. Also have an MFA in fiction writing. And I became very interested in how kind of merge these two, how scientists and engineers, how we should communicate our work. And so first became very interested in writing, and so I do quite a bit on writing, but probably in the 1990s, I became deeply interested in presentations. And so been kind of studying, the way I did writing the way I did presentations is the way that I approached writing. I looked at the best presenters in science and engineering and just tried to figure out what is it that they do. Kind of look at best practice. Didn't really pay much attention to the axioms that people always talk about. Tell them what you're going to tell them what you told them, which works a lot of the time, but if you've got an audience who is dead set against the idea, that one's not going to do well for you. But I did pay attention, and so when I was starting out, there were people like Richard Feynman, Jane Goodall were some of my heroes, Linus Pauling. But then there have been other generations have come up, Brian Cox, Jill Bolte Taylor. So a lot of good presenters have come up, and that's in a sense where I have been focused. Up here is Cheryl Hayashi, who is, she's biology, but she's one of my favorite speakers. So I became very interested in what is it that they do that most scientists and engineers do not do. Now I know we've got some people from social science, we've got them from maybe some different aspects, mathematics and things. You might be thinking, well, is this going to apply to me? I do teach quite a few places, and I do teach, I'd say pretty much anybody who is presenting with the goals of informing and persuading an audience. I think the things you'll learn today will apply. Now, we're gonna focus on research presentations. So I'm thinking about that presentation where you go to a conference and then you present your work in your audience. You probably got experts in the field. There may be some grad students, but you've probably got faculty, then you've got professionals who are there. So that's when I talk about a research presentation, that's foremost in my mind. But I do coach a lot of people who do presentations in industry. There's a lot of industry-sponsored research, for instance. And then also there are a lot of talks that are not necessarily a conference, but within your group where you are communicating kind of real recent work that you're doing, kind of progress reports. So I'd say a lot of the things that I'm going to talk about apply to that. Now it's kind of interesting. I'm going to kind of jump a little bit in that we're going to focus a lot on slides. And you might say, why? I mean, slides are they that important? And to be honest with you, when I started researching presentations, I kind of thought slides were kind of something that you did at the end. I didn't think it necessarily had a big effect. But what I have learned is that slides make much more of a difference for the success, and I'd say maybe more often the failure of scientific presentations than people realize. That a lot of people follow PowerPoint's defaults, and they create slides that end up pulling down the presentation. I mean, if you want to look at it just from a signal perspective, there's a lot of noise in the slides that most people show. So that's a little bit of why we're going to kind of focus a lot there. I'd say another thing is when you're creating slides, you are actually making a lot of decisions that affect the structure, the scope of a presentation, and so that's the reason it's important. I'd say another thing is when you create those slides that a lot of people create, their delivery becomes affected. They end up turning and reading a bullet point, turning back to the audience, reading a bullet point, turning back to the audience. That becomes tiring really fast, and so that pulls down the delivery. So that's a little bit of why that focus. In terms of resources for you, two things. One is my book, The Craft of Scientific Presentations. I've got 4 copies on reserve in the engineering library. I think there's some that are scattered throughout libraries on campus. If you want to purchase a copy, or you can talk your advisor into purchasing you a copy, you can get one for $32, $33 from Amazon. Amazon's the cheapest. That's often where I buy it. And another site, it was one that I sent you for the preparation assignment, is assertionevidence.com. It's easy to get to. You don't have to kind of remember those words because they may be kind of, they're ones that you might forget. But if you just type in engineering presentations, it's usually the first or second site that is listed. Scientific presentations, my book is on the first page. If you Google that, in terms of a search term and things. But yeah, engineering presentations will work the best. Scientific presentations, it works okay. So that's a site. I would have to say that what I'm going to talk about today has been deeply affected by the places where I have presented. So, beginning like 2002, people started, some people kind of got wind that I, was working on this book, and they knew me from writing, and so they started asking me to come in and talk about, what I had learned about presentations, and I learned a lot by teaching, because boy, when things did not work, let's say in a certain laboratory, so Sandia National Labs is a place I've gone, Lawrence Livermore National Labs, Los Alamos National Labs, Lawrence Berkeley National Labs, Brookhaven National Labs. I've kind of done the National Labs tour. And so a lot of things that didn't fly there, and in different disciplines, I would get pushback. And so I learned a lot from that. So I did a lot of universities and laboratories, some companies in the US. I've been doing a lot more companies of late. Texas Instruments is a big one that I go to. But then it wasn't just in the US, it became international. For some reason, Norway became really interested in the ideas. I've been to Norway every year, at least once a year since 2003. And I do a course that's actually a national course for graduate students there. I went back, I'm sorry. Yeah, and so I kind of wondered if what I was going to be teaching, if it applied to people for whom English was not a first language. And I think that there are some subtle things, but I think actually a lot of the big principles actually are the same. China now is a place I go to almost every year. Shanghai Jiaotong is really interested in some of these ideas. So what I would say is there are a lot of people who have become interested in these ideas, even though they are not the norm at conferences. What I'm going to show you is actually quite different from what you see faculty, for instance, when they present seminars on campus. But there are quite a few people who have used, who are starting to use this approach. And there are a number, I'm showing quite a few graduate students here. number of graduate students who have tried to use this approach and had quite a bit of success. Katy Kirsch in the lower left, she's probably, she's my poster child. She started using this approach as an undergraduate, and actually as an undergraduate researcher, she went to an international conference in Prague and won best presentation in the master's category against 25 others. And graduate students. She wasn't a graduate student. She wasn't even a senior. She wasn't really even a junior. She was just a sophomore. But one thing that I'd say is really important is she had good content. You have to have good content, for people to see value in your presentations. But what this approach does is it allows people to understand that content. Okay. Think of signal to noise ratio. We really try to reduce the noise is something. And then there are a lot of these other people, either Sazam Atatürkür, who's now department head of architectural engineering. She used this approach in her presentation to become a faculty member at Clemson. And she said that was one that people had said really distinguished her. Terry Johnson, aerospace engineering. Jimmy Weber in the light blue shirt, forestry. I know I've got a forestry person in here, and then some others. But a lot of people have won best presentations at conferences, and so that's what I would say is maybe something about this approach that distinguishes it. That there are not necessarily a lot of people using it, but the people who have used it have had quite a bit of success. Coming back in terms of just some assumptions, I'd say the biggest assumption that we're going to make is that when we present, our main goals are that the talk is first understood, second, that it's remembered. And I think having your work being remembered is particularly important when you go to a conference. I mean, if you think, how many of you have been to conferences? Okay, so I mean, you think about the conferences that you've gone to, and think about all the talks that you see. Maybe you see 20, maybe you see 30 talks. How many of them do you really remember? And I don't know. I mean, I think each of us would have a different answer. But for me, usually, when I come back from a conference, there are maybe 4, sometimes 5 that I remember. And when I present, I always want to be in that 4 or 5 that people carry back. Because I think that's an important way in science and engineering that your work gets communicated or spreads. That people, they heard your presentation, they remember your presentation, they look up your papers, and then really they learn about it. And then believed. I mean, believed is important. You can do a lot of things. People can understand you, they might remember you, but they have to believe your work. And then I would say a personal goal, and this is from working with a lot of graduate students, just has to do with confidence. I mean, it is hard as a graduate student to present at a conference. I mean, essentially what the situation is, it's kind of like, it's kind of like baseball. I mean, you don't go to like, well, okay, I'll get high school pitching, and then I'll get, single A, double A, triple A pitching. I mean, what happens is being a graduate student, you go to a conference, and boom, man, it is major league pitching coming at you. I mean, the questions that the audiences will ask are going to be the same that they would ask anybody. And so I think that in itself is intimidating. I know when I presented as a graduate student, man, I was scared to death. Somebody was going to ask me questions that I couldn't answer. I mean, that was probably my biggest fear. And so I want to talk about, I kind of want to work in how to get more confidence, because that was a surprise that we found in this approach, is that people just kind of unexpectedly reported that they felt as if they had much more confidence when they were presenting with this approach than the common practice. So, just kind of a big picture thing, because I said I was going to focus on slides, but let's think about what distinguishes the best presentations in science and engineering. I would say number one is that the best presentations in science and engineering have good content. If you don't have good content, it doesn't really matter how smooth you are and all those other things. I mean, in the end of the day, the audience isn't going to get any value from that talk. So there's got to be content there. And Stephen Hawking is my hero here. You know, Hawking, when he was like 21 or 22 years old, I think a lot of you know his story. He had this debilitating disease, and so he could no longer stand tall, the things they tell you in speaking books, and he could no longer project his voice, those things that they tell you in speaking books. But man, that guy filled auditoriums wherever he went. And the reason is, it's content. I mean, when you went and listened to him for 30 minutes or 45 minutes, and you learned a lot of valuable things, or maybe not necessarily valuable, but interesting things that you took away. So I'd say that's one. A second thing is this idea of passion. You've got to show that you care about your work, because your work, I think I would venture to say everybody's work in here, when we start to present it, the trail is going to get steep for the audience in terms of them trying to understand you. And you've got to give them motivation. And if you don't show that you care about the work, then, you know, when the going gets tough, they're not going to have they're not going to have that reason, you know, a motivation, at least from the stage, to care. So I'd say that's important. Now, I've got Hans Rosling here. How many of you have seen a talk by Hans Rosling? Anybody seen? He's a World Health statistician. He just passed away actually a few weeks ago. Nobody's seen his work. 2006, watch his TED Talk. It's incredible. The guy is, people talk about, when he talks about, he's talking about a graph right here. When he talks about that graph, people talk about, it's like he's calling a horse race. And even though you may not have cared at all about World Health statistics, man, all of a sudden you're in it. Man, it's like the Kentucky Derby. And you're really excited about what's going to happen here, because it's pretty cool. He developed this software such that it's really a scatter plot, but a scatter plot that changes with time. And so he looks at longevity in different countries over since the early 1960s to the mid 2000s, you know, and wow, it is just, I mean, it's fascinating. But not all of us have that exuberance when we present. So I'm not necessarily saying you have to be exuberant or you have to, you know, kind of adopt a different persona, but you need to have a sincere enthusiasm for the subject that you have. Okay, and so you look at a Jill Bolte Taylor. She's a lot more low key, but boy, she cares about her work. You can see it. I mean, there's sincere enthusiasm. And then the third aspect is this keen sense of the audience, and that's where we're going to start. I mean, before you begin a presentation, you need to think about audience. And so Jane Goodall's my hero here. She doesn't matter whether she's given a technical paper in London, or she's raising money in Nebraska, or speaking to school children in Singapore, or negotiating with tribal chiefs in Tanzania. She really has that sense of audience. And so here's my question. Here's a question I have for you. I mean, each of you, when you go to a conference, you've got an audience, and And you may have multiple audiences. You may have experts in the field. You may have people who are kind of in the area but not necessarily experts. And so you've got these different people, and so maybe you've identified them. But for each of them, what would you say are important questions for you to ask? Yeah, very good. Michelle? Yeah, so Michelle says, what is it that they care about? Okay? And I would say that's a question that a lot of engineers and scientists don't ask. And it's really an important question to ask, because that's going to affect what it is you're even going to present from your work. Former department head of chemical engineering at, here at Penn State. He said that, in the writings and in the presentations of graduate students, the biggest mistake that I see that they make is that if they spent 90% of their time on X, then 90% of the document or the presentation is about X. Even though, from the audience's perspective, the most important part was in the 10% that's Y. And the best speakers will ask the question that Michelle just raised, and we'll think about, really from the audience perspective, for my work, what's most important. So I'd say that's one. That's not the first one I have up there. That one actually, though, that's the more subtle one. Yeah. There's another important question to ask. Yes, sir. Okay, very good. What's your name? Samid. Yeah, Samid here. Really, really important question. And so I say it in a different way, but it is, what do they know already about my work? And so in that regard, what am I going to have to fill them in on so that then they're going to understand things? Okay? So that, I'd say, is one, and then what Samid said is one, and then Michelle's question, I'd say that's two. And as I mentioned, that first question, that Michelle's question really kind of defines where I'm going to focus the presentation. And then Samid's question, how am I going to get the audience up there so that they can follow me? And so at this point, I just want you, because I want you to have a presentation in your mind as we walk through this approach that you're going to learn today. So I would like for you to find somebody. I know some of you, I just want to be by myself. No, I want you to find somebody, and I want you to talk about your next research presentation. It could be a conference that's like a year from now. It doesn't matter. But analyze the audience as best you can. Who they are, what they know about the work, why they are in the room. Go. Got to. Yeah, I'm fussy. You can have groups of threes there. Good. Again, I know y'all are, you're doing, actually, these are really important questions to ask. And so I know a lot of you are getting into it now and you're really thinking about your presentation. Fantastic. But we got to keep, we have to cover some things. So we're going to have to keep moving. But those are important questions to ask. But I hope that you've got a kind of a presentation in your mind that you see yourself giving. So, what's this approach? And so I'm going to give you just an executive summary of it. And the first principle is actually the hardest. And it seems like, oh, that's real simple. Everybody does that. Well, no, they don't. But it is to build your talk on messages, not topics. Most people, when they build their talks, they build it this way: introduction, methods, results, discussion. And so it's kind of at that level. And that's fine. All of us actually are going to do that when we do a research talk. I mean, we're going to follow that kind of path. But what I want you to do is I want you to be thinking about your talk at more of a message level. So it's not just introduction, but what is your research hypothesis? Or some of you might say, what's my research question? So that's important. And then, yeah, you'll talk about motivation, but I want you to think about what is it? What is the reason that people are going to be most interested in my research? I mean, think about it at that level. Or on methods, what are the features of my approach that distinguish my approach? Or maybe what's the feature that makes it the most credible? All right? That's at that message level. And then, second principle is support those messages with visual evidence. Primarily visual evidence. Could be photographs, drawings, diagrams, graphs. Could be films. Could be equations. Could be small tables. But support it that way, not bullet lists. Most people just support it with a bunch of bullet lists. And I got to tell you something, bullet lists, those are your notes. And the audience, yeah, they may read them on the first slide, second slide, third slide. Gets to slide 8, man, they're tired. Particularly if it's at a conference and you are speaker number 4 in a session of 5. I mean, and then this is the third session of the day. I mean, a lot of people aren't going to read it. And so you get a bad dynamic. What happens is you're up there, you're reading text on the screen, and the audience is watching you read text on the screen. And that's where I see a lot of presentations kind of fall. We can do better. We can do better than that. So that part's tough. It may seem hard at the beginning, but it's not as hard as you think. And then the third one is that you got to learn, because we're kind of letting go of the bullets. You got to learn to fashion sentences on the spot that explains that visual evidence. Now, when I say fashion it on the spot, I don't mean just go in there and wing it. You're going to plan the talk. You're going to practice the talk. But you're not going to say the sentence the exact same way each time. I usually fall in love with certain transitions, and so I'll use those almost every time. But I'm not wed to those. And that's, I'd say, is important. And that's quite different from the person who keeps turning back and reading the next bullet on the list. Those are the 3 principles that we're going to go for here. So, I'd like to, what we're going to do is we're going to kind of put together a research talk. We're going to do it a little differently than it's typically done. But I'm going to use this analogy that when you present your research, in a sense, you are a Sherpa guide. You are leading that audience up the mountain of your work to give them this vista, this understanding that you have of the subject, okay? And so you don't necessarily go to the top, because that may be, you may not quite understand the top, but you go to, let's say, a saddle point, a place where you you got the vista, you understand what it is that you're seeing. So that's why I kind of draw the picture in this fashion. And so then in terms of a research talk, you can think about it as Aristotle did, beginning, middle, and ending. But I would say about the beginning for us in science and engineering and in, I'd say just in research talks, the big thing is you've got to orient the audience, okay? Because the audience, particularly at a conference, is coming out of another talk, and it may be in your area, but you've got to orient them as to where you're going. And that is so important. How many of you have ever been to a seminar where, I mean, you were lost at go? I mean, I've been to seminars where, boom, man, all of a sudden, the person's up there, you got the person's name, and then all of a sudden you're looking at this bank of equations, and you have no idea what the terms mean, what they're standing for. You don't have any image, to anchor it with, and you are just like, oh my gosh, why did I sit in this seat? I should have sat in the back there. Then I could have gotten out, or I should have brought my cell phone so I could at least do email or something. I mean, it's just, it is totally painful. So beginning is real important in a research talk. And then the middle, I'd say the big thing is, how do you keep the audience with you even when the trail gets steep? That to me is a really tough question. So that's one we'll focus on. And then at the end, the end is an opportunity for emphasis. We talked about the importance of your talk being remembered. The ending is where you have a chance to solidify that the audience will remember your talk. A lot of people fumble the ending. We'll talk about how not to fumble, the ending. How to end in a graceful fashion, and to make that transition to the formal question period. Okay. So that's where we're going to go. But here's where the funny part is. I kind of want to start in the middle, because middle's a little bit more straightforward in terms of talking about this approach. Then we'll come back. We'll talk about the beginning, and then we'll talk about the ending. Okay? We'll take a break here about 2:25, and then 2:35 we'll come back, and then we'll finish. So that's kind of our game plan. How are we doing? Sounds good? All right. Okay. So where I'm going to start is kind of sad, but I kind of want you to think about the slides that you typically see, okay, in conferences. So I picked a conference, and I got this slide from that one. This may not be the slide that you typically see, but slides that you typically see, I want you to think about those. And if you could wave a wand, and this is as an audience member, what you would change. What would you change about the slides? I'd kind of like you to talk to a neighbor and think about it, okay? So there's a slide from a conference that sometimes I attend. But I would like you to just think about the slides you typically see. What would you change? Turn to a neighbor real fast. I'll give you 60 seconds. Talk about what it is you would change. Go. I just showed you part of the slide. I didn't show you the whole slide. You can guess what it would be, Okay, stop. Nominations, things that you talked about Anybody? Yes, sir. Alex, you.
I'd probably get rid of like 9% of text.
Okay, how many groups had too many words? I got to tell you, I kind of knew that was happening. Yeah, I kind of knew that one's happening. Too many words. That is the number one thing that I hear people say. And it's like, I used to do more formal surveys, and it was like 85, 90% of the groups would have that as one of their three things. And at first I thought, well, maybe that's just a U.S. thing, that people who are maybe presenting in a different language, you know, not their native language, they would want the scaffolding to help them. They say they say in Shanghai, in Oslo, they say the same thing, man. Too many words. This is the number one problem. And here's why. Here's why it is. And it actually comes from some research that was done in the 1990s, okay? And you have to understand, an important thing I'll be talking about is that PowerPoint actually came out in the mid-1980s. And there's been a lot of research since then that maybe challenges its defaults. But you've got a speaker, so I've got a great speaker, Joe Bolte-Taylor. You've got an audience. I mean, we've known since we were cognizant as people of knowing that there are going to be spoken words that she's going to say, and there are going to be written words that she might show. So about the same time that PowerPoint came out, there was this Canadian psychologist by the name of Alan Pivio, and what he found out is that, or what he determined is that even though you've got written words that are seen through the eyes and spoken words that are taken through the ears, he found out that they are processed in the same part of the brain. And so that result kind of stood for a while. And but then there was an Australian researcher by the name of John Sweller who said, wait a second, if you've got written words and spoken words processed in the same part of the brain, could that part of the brain become overloaded? Much as a central processing unit can become overloaded if it tries to do too many tasks. So he did experiments. He had a room full of people, and they just read things on a screen. He had a room full of people, and they just listened to somebody hear those exact same words. Then he had a third room where they're hearing the words said, and then some of those words are on the screen. Okay, so kind of like a presentation. And then he just kind of amped up the number of words to see if it made a difference. So when the words are really low, actually, the group that was reading and listening, they were doing the best. But when the words got higher, then people would reach this kind of overload situation. And what he found there is actually that group went from number 1 to number 3. Okay, they did the worst. And and so this result you think would have affected a lot of people, but it really hasn't. But it should. As my counterpart in Europe, his name is Jean-Luc Dumont. What he says is that he says that bad slides actually are worse than no slides. That you would do better if you just didn't have anything on the screen than to have too much text. And this idea of how much is too much, that's kind of hard to pinpoint. It depends on who exactly the audience is, how tired they are. I mean, there are a lot of factors that go into it. But what Sweller says is what most people do, and most people in science and engineering, they project 35 to 40 words per minute. Okay? He says that's a disaster, that the audience becomes overloaded after 3 or 4 slides. They may stay with you for a while, but then they become overloaded. Most people, and actually we did that research here at Penn State, in science and engineering, and I thought it would be different among teachers and professionals, students and teachers and professionals. Nope, all the groups about the same. 35 to 40 words per minute is what people project. That's too much. So that's why that one's number 1. Others, there are no wrong answers. A common one that people will also cite is that the slides are cluttered. It may not necessarily be words, but it might be even little images and things. But the problem that people say is they don't know where to be looking when the speaker is speaking. That they're not in sync with what it is that they're reading. And then a third thing is, and you can see it in this particular graph, which is probably the money part of that slide, you can't read the axes. The axes are too small. And if you can't read the axes of a graph, man, the value of that graph plummets, all right? So having text that's too small, it also ticks off people in the audience, all right? That's one that people really become irritable about. Those I'd say are the biggest three. There are no wrong answers. People will talk about other things, unprofessional animation and all sorts of stuff. But I would pay attention to those three when I'm creating a presentation. Now, a question comes, why? You know, because scientists and engineers are pretty good at evolving. How come we haven't kind of evolved out of that? And what I would argue is that PowerPoint's defaults kind of lead us down that road. Now, here's a little bit of history about PowerPoint's defaults. As I mentioned, they were created in the mid-1980s. They were created by an entrepreneur by the name of Robert Gaskins and a computer scientist by the name of Dennis Austin. And this was in Silicon Valley, and they addressed a problem that you don't know about, but it was one that my generation knew, and it was that, dang, it was hard to make a slide. I mean, because the only way we could make any type was on an IBM Selectric typewriter at that time. And that was like, you use the biggest ball they had, that's like 12-point type. That's not very big. And then you'd go to a copy machine and you would blow that up as big as you can. And you'd go do that a few times. Then you'd take scissors, you'd cut out the type. Then you'd paste it on a piece of paper. Then you'd send it through this thermal transparency maker. It was a lot of work. And so, but these guys, so this is way back when, you know, computers were primitive compared to what they are now, but they figured out a way they could scale the type. And so that was basically what they did. And then they packaged it as a way to make presentation slides. Now, at the time, they couldn't put any images in there, but that's okay. This was still an advancement. Here's the problem is that, okay, so what they came up with really wasn't based on any research. So that's one. And then number two, it hasn't changed that much. I mean, yeah, they went from Times New Roman to Arial to Calibri. Yeah, they put in, you know, little Microsoft's little package, but you still get all this text. And it's all this text. It just leads to too many words. So you have to understand a little bit. The guy was trying to sell a program. He didn't really have all those nested bullets when he first started. But everybody kind of looked at it and said, this is no big deal. So he kind of added all those nested bullets, this sub, to kind of give it more heft, you know, the design. Because he was trying to sell it. But then they kept those. I don't know why they keep those. But anyway, it leads people to create too much text. It also takes up really valuable space where you could have had a much bigger image that then people could read the axes. And then a thing here at Penn State we've been focused on is this idea of about 85% of people when they create a slide up in that whatever size font it is that they use, 40, 44 point, they write a phrase. And we kind of ask why. Why a phrase? How does that help the audience understand, remember, believe? Don't have an answer for you because I don't buy that. But those are the three things there that are happening. And what I'm going to say to you is, man, we can do better than that. We can do better than that. So there are a lot of people who have criticized PowerPoint, Edward Tufte and others. I like this one. The real mystery to me is why PowerPoint's default style has been adopted so widely. Why do medical researchers use this style at conferences? Why do engineers use this style for technical discussions? And the reason that I like this one is that guy right there, the person who said it, is none other than Robert Gaskins. This is the guy who created the program. And he's kind of like, what are y'all doing? How come you're using all this bullet stuff, man? You know, I just kind of put those in there, all right? I think that one's interesting. So let's talk about what to do. And before we talk about what to do, just a couple of assumptions. The first assumption is actually you need a slide. And I think this is kind of a really important assumption. I think it's good to go through, do I actually need to show a slide? Because if you don't, I would show that on the screen. Actually, it's my favorite scene in a research presentation. It's just where the speaker just kind of looks at the audience and just kind of talks to them. And very few research presentations show that scene, although they should. I mean, it's a great moment because then the audience looks at you. When I have undergraduates who present at conferences, sometimes I take them to these engineering education conferences. I always have them put this scene in there, and I always tell them I want you to walk to the middle of the floor, okay? Stand right in front of the projector because there's nothing coming out, and talk to the audience. And people will say, man, your undergraduates, they have so much confidence. Now, I know the undergraduate was looking green in the morning, you know, was scared to death. But, but there's something about just that move. And it may be kind of when you talk about yourself. I think when you do acknowledgments, I think it's a cool time to do it. And rather than show a bunch of just a bulleted list, I like to point, I'd like to thank this person, I'd like to thank this person. I mean, that's actually kind of personal, kind of, you know, that's just a thought. Anyway, somebody who used this scene quite a bit was this guy in his. I mean, he thought about his presentations. He thought of them as, I use this word loosely, but he thought of it as a story. And every slide was a scene of that story. So TED Talks, they like to think about it in that way. And I mean, I think that's fine. I think that's easier said than done, though. A lot of people say, yeah, you got to tell stories. But I think that can become misinterpreted. But I like this idea that really every slide is like a scene in this research story that you're telling. And if he didn't have anything valuable there, he showed the blank screen, and then the focus came to him. You know, truth be told, in a conference talk, you might have maybe one time where you can do that. Because conference talks are kind of a compression of research you've done over a year. And a lot of times you need to be showing images that show your methods, that show your results and things. But I like this exercise that you really think about, do I need a slide? That's number one. Number two, I think one thing that holds a lot of people from the approach that I'm teaching is a lot of people are sold with the idea that the slides also have to be handouts. And if you think about it, the slide should serve the audience in the room who's listening and reading, and the handout should serve people afterwards who are just reading. And those are two different communication situations. I'm not saying you can't use slides as part of the handouts, but one thing we've been thinking a lot about is using the notes page. I criticize PowerPoint a lot, but I think the notes page was a brilliant feature that Gaskins and Austin put in right at the beginning that very few people use. But I think you can create an incredible handout with the notes page, full reference citations at a type that people can actually read. So anyway, that's another thought. So here we go. We're doing great. 2:20. I'm going to introduce that first. So we may go to 2:30 and then we'll take a 10-minute break, whatever we do. But I'll introduce that first principle and we'll work through it. So as I said, it's build your talk on messages, not on topics. So here's what most people do. Most people, let's say you're doing a research talk, and in your research talk, maybe you're talking about additive manufacturing, 3D printing, okay? But you've got its application, we'll say to jet engines is your application. And they'll kind of think, oh yeah, we got to talk about what type of 3D printing am I going to be using. So we're using powder bed fusion, And then why did we choose that? And then they'll put in a whole bunch of bullet points that kind of, the things they want to say. And then if there's any room, they'll put an image. And what I'm saying is, don't go there. You can do better than that. Think about what is the message you want for that scene. So we're going to spend a few more words, but you're going to end up saving words at the end. So Jacob Snyder, in his presentation, some of you, I think like 17 or 18 of you watched Jacob's talk. I was watching the statistics earlier today. And he thought about this question, and what he realized is that powder bed fusion was, had a lot of advantages for creating parts for a jet engine or a gas turbine engine because those parts needed to be really, really small, and they needed to have very intricate details. And powder bed fusion, that's its strength. It's not really good at making big things, but it's really good at making intricate small things. That was the message. And once he had the message, then he was in a position to come up with some visual evidence to support the message. And so in this case, he just took two examples. He took a fuel nozzle that General Electric had created, and he also took a gas turbine blade, some of the channels that Siemens had created. So he used two examples to kind of back things up. But you notice in the body, very few words. So we're nowhere near the 35 to 40 where most people are. We're more, given if you look how long he presents this, about 20. So that's about half of what a lot of people do. And when you craft these really well, they essentially tell the story of your research. They're like an abstract of your presentation. The northeastern growing season and landscape are not suitable for common fuel crops. Miscanthus is well suited to the growing conditions of the Northeast. Because it is perennial, Miscanthus is well suited to the landscape of the Northeast. And in terms of energy output, Miscanthus is 4 times more energy efficient than corn. I mean, that, in a sense, was the abstract of Daniel Lesso's talk about possibility of using Miscanthus as a fuel crop in the Northeast. And it's those headlines. I mean, they're the money. And they're in the biggest type. Most people will put introduction in, as I said, in 40-point type and stuff like that. It'll take up a lot of the screen. Well, the audience already knows that you're going to do introduction, methods, results, discussion. They already know that. But they don't know these messages. So this is a good place for us to break. I'd like you to, some of you created slides. You downloaded the template. Others of you maybe not. But what I'd like you to do is I'd like you to create some. Don't worry about creating slides, but think about what would be the most important messages for the audience to walk out the door with. Come up with 2 or 3 for your research talk, okay? So we're going to take a 10-minute break. If you haven't signed in, Laylee would love it if you did. Are there handouts still up there, Laylee? They're online, and so I'll go back to where you can find those. All right? Sounds good? We'll take 10 minutes. When we come back, I'll start with questions. So I'll take some questions from you. Cool. $2:35. We start back up. this is where you can download it from. Handout for today. will do it. Other questions people have? Yes?
How do you feel about lots and lots of things popping up over your
So, I mean, animation can serve an audience. If you've got a really complicated, think of a flow diagram, and if you showed everything at true color, the audience wouldn't be sure where to look. So what a lot of people do is they'll have the flow diagram, they'll have it light gray, and then they'll bring in parts so that then your eye will go, oh, okay, there's that. And so I think that animation, I think that serves. But if there's too much just continually happening, I think that can tire an audience in a different way. I think it needs to be purposeful. That's a good question.
Because I used a lot of credit before.
What?
Credit.
Yeah, okay.
I wonder if, using PowerPoint is kind of interesting rule, or I don't see many people using credit. I saw like 1 out of 10.
Yeah, so Prezi, other programs, Google Slides and Keynote, and in Europe they use something called Beamer. They've all kind of sadly, they followed PowerPoint's defaults. I wish somebody would challenge the defaults, is what I wish somebody would do. But they feel as if we're going to get a market share, we've got to mesh with what PowerPoint does. The only one that doesn't is Prezi. And so Prezi, rather than having what they call a deck of slides, Prezi has a big map, and then you just focus in on parts of the map. And I think the thing that holds Prezi back is, number one, you still have to, every scene, you have to design that scene. And I don't think that they do anything. I think in a way the defaults are kind of close to what PowerPoint does. So that's a weakness. And I'd say another thing is it's a little more difficult learning curve. I mean, PowerPoint is easy, which is a reason that I think it's entrenched. Is it's just so dang easy to use. Yeah. Had a question about all caps versus upper and lower case. I'll talk about that one in a little bit here. But I want to move on to the second principle. Support your messages with visual evidence. Photographs, drawings, diagrams, graphs. Could be films, could be equations, but not bulleted list. And so here's the psychology research behind this one. So it goes back a little bit to that Alan Pivio, is that, he had found out that words, both written and spoken, were processed in one part of the brain. What he also found out is that images were processed in a different part of the brain. And so a lot of people, probably Richard Mayer from UC Santa Barbara, kind of being the leader is well, gosh, if the audience can learn with images in kind of this different path, man, why don't we use images on every scene? And so then there's been a lot of research. How valuable are images in how much people learn? And so, I mean, the big principle that people take away is, I have a new advancer and I'm just learning to use it. Very sensitive. But the big takeaway that people have is that people, that audiences learn much more deeply from words and relevant images, not just art, just put in for art's sake, but relevant images than words alone. And that is, to me, real opportunity, is that and a lot of visual evidence has word components as well as visual, but you think about a graph, it doesn't really have many words. It's got the y-axis, it's got the x-axis, and then But then you've got these wonderful curves, and that then are being processed in the visual part of the brain. And so there's such an opportunity here to reach that audience that's kind of probably overloaded with too much text written and spoken. And so that I'd say is a big takeaway. So let's kind of look at an example. This goes back to Jacob Snyder's presentation. So he's a graduate student, PhD student here in mechanical engineering. He's been looking at using 3D printing, additive manufacturing for these jet engines. And a real important or a real opportunity in a jet engine is to design these intricate and very small channels. These are kind of cooling channels. Because the big game in jet engines is that when you burn that jet fuel, it gets really, really hot. And it can melt the blades and vanes downstream. So you've got to cool them. Because it's not a good thing if they melt, particularly when you're at 35,000 feet. Not good. So, yeah, because if those blades and vanes melt, then the plane comes down. But anyway, so in this particular scene, he looks at creating this cylindrical cooling channel. So it's just a cylinder, but it's really small. And so if you look at the axis on the left, you see that we're talking a radius in millimeters. Okay, so man, millimeters are small, and we're talking actually the dimension that the true dimension that they were aiming for was 0.25 millimeters. So now this cylinder was created vertically. Okay, so it went up like that. So you had this powder bed fusion, and it's kind of creating this cylinder, and it's just kind of building up and up and up. And if you look at it, what you see is it's not just one color. You get a gradation. It's kind of a reddish and a kind of a yellow and orange. And so what's happening is it's not exactly 0.25 millimeters. I mean, there's a little bit of variance. But what if you built it horizontally? I mean, so instead of the cylinder going like that, what if the cylinder went like this? And so then you start building from the base, and so you're kind of creating it. It's kind of coming up in that fashion. And so when he did it in that fashion, then that's what it looked like. And people hadn't. That was something that was kind of new. Nobody kind of looked at the effect of build direction on this, how true the dimensions would be. And so you see, whoa. I mean, that's not very, you get a lot of blue, so you see there are a lot of places where it kind of sunk down, particularly at the top, where it couldn't support it. And you could build it at different angles. So here's one at 45 degrees. So it's a little bit less kind of, wavy as this one, but it's still quite a bit. And so you might look at it and you might say, oh, well, this is obvious. You definitely build them vertically. Except that in heat transfer, sometimes when you have a rough surface, you actually get better heat transfer characteristics than when you have a smooth surface. And that's what became very interesting to people here is well, we could maybe tilt some things, in certain directions and maybe promote some type of that kind of roughness to be in there. And that's why this particular slide, he said he's shown this slide, in 5 or 6 different presentations in front of full rooms that people are really interested in this work. But this slide is a great slide, I mean, in the sense of how much that he communicates to an audience. And so let's kind of break it down. I mean, it starts with the message. As I told you, the first principle is, I think, the hardest, and it's probably the most important, because what it does is it focuses you as a presenter. And to me, I am convinced that Richard Feynman, Jane Goodall, when they think about their presentations, they don't think introduction, method, results, discussion. They are really thinking about I've got to communicate this message and defend it. I've got to communicate this message and defend it. And those messages are like steps up the mountain that you're leading your audience. Now, that's from the presenter's viewpoint. From the speaker's viewpoint, from the audience's viewpoint, some of you are saying, hey, look, I saw you give that slide. I got it. I never read the message. And I would say, fantastic. You were on your game as a listener, and I happen to be on my game as a speaker. But you zone out. It's the fourth talk in a session, and it's the 10th slide. I mean, you zone out. You start thinking about your dog. You wonder, what's my dog doing? And all of a sudden you step back in. Hey, I'm at this conference. I got to focus. That message is a safety rope for you. That lets you stay in the game as far as an audience goes. And that's so much more valuable than looking up there and grabbing the word results. Results doesn't help at all, okay? It tells you the topic, but it doesn't tell you the takeaway. Now, granted, you may not get all the details that are spoken in that scene, but you get the main takeaway. You can stay in the game. A couple of things here about the message. One or two lines. It's not just, I've done focus groups, but other people have done focus groups. If a text block goes more than 2 lines, audiences really drop off in terms of reading it, because it seems as if it's too much time away from the speaker. I'd say another thing is this whole idea of capitalize it the way you would a sentence. So if you look at modern newspapers and things, you see that's the way that they've gone. It's much easier for the audience to read. And don't do all caps, because all caps doesn't let you see, that forces you to read every single letter, because you can't recognize words by their shapes, which is something that we do. I think those are 2 lines, initial caps. Yeah, left justified. People are accustomed to reading sentences that are left justified rather than centered. The only place we ever see centered headlines, that would be, on tombstones, okay? So you're presenting to live audiences, left justified. A lot of people ask, period? There's no period there. Well, it's a standalone sentence. It's not needed. But look, if you've got this voice of an English teacher who says, always put a period after a sentence, put the period there. It's not that big a deal. But do think about where you break the line. I mean, artists will tell you it's a good idea that the top line be longer than the bottom line, or at least as long. And reading experts will tell you, try to keep phrases together, that it becomes easier for people to read, because people actually don't even read single words at a time. We often try to group words when we're reading quickly. Yeah. And don't have a single word on the second line. Does anybody know what that's called? That's right. It's called an orphan word. Makes people sad. Don't do that. Okay, so that's that one. The visual evidence, I would say, think about the clutter. Try to keep things, have some white space so that the slide breathes. I'd say that one's important. And to be effective, the visual evidence needs to be engaging for the duration of the slide. And so that's why maybe sometimes animating something in. So in your case, you had like 3 graphs. I might have started with 1 graph, explained it, then brought in another, and then brought in another. Because, yeah, graphs take people a while to process. Cool. Yeah, and so that's what Jake did. I mean, and he explained this one so that you understood what the situation was. Then he animated in the horizontal one and the one at 45 degrees. Have something there, though. Don't just have like white space. Just white. Well, we've all seen kind of horror movies, And in a horror movie, don't ever look into the light. It's kind of a little bit the same thing. Is that you don't want your audience kind of gets blinded by that, and there needs to be something there visually to kind of soak up their attention. So cool. So now here's a suggestion that I had in the prep assignment. Is I'd like you to create a slide, but I'd like for you. Don't just open up PowerPoint's defaults. Not a good place to start. And it kind of sends you down a bad road. Use one of the artist templates. And so these templates, they've come from our national laboratories. Lawrence Livermore contributed to it. Sandia National Laboratories contributed to it. So a lot of thought has gone into the templates. They don't look like much, but that's where I would go. So go to assertionevidence.com. I've got black backgrounds, I've got white backgrounds, I've got the 4x3, I've got the 16x9, It kind of depends on what your group perhaps expects. So give you a little bit of time to work on that. And it'd be nice if you've already created slides, kind of get together with somebody and kind of get some critiques. So let's go. Even if you don't have a computer, piece of paper. You can do a lot with just a piece of paper. Yeah, you're kind of starting with the defaults there, Can you not get on the web?
I can get on the web. I just had a slide I had made already.
Okay. That's a good question. I think black's cool. I mean, every lumen counts with black, so I kind of like it in that regard. Some people, they have to print out their slides, and you can do that with black and kind of get it, do it, but it is a little trickier. Also, if I don't know that the room's going to have good lighting, black is maybe not as visual as white. And then one other thing, like if I am incorporating equations or graphs, white's kind of seamless. So what I do a lot of times at a conference where I'm not sure what I'm going to get, I'll go white. But if I'm going to do something, what?
Feeling daring.
Yeah, and longer presentations, I like to go black, just because I think white wears people down after a while. It's just a lot of lumens. Yeah.
Does that depend on like the amount of space that your figures are taking up?
I don't know. Just, I have done white for 45 minutes and stuff, but in these workshops, and I'll show white slides, but I don't know. I kind of went black, and for most of the teaching ones, I kind of like it. But I'd say either one of those is good. You don't want to do something that is in the middle of the color wheel, because then it doesn't have enough contrast. So I'd say, yeah, it's kind of, that one's more your preference. Any other questions anybody has while we're working on this exercise? These are good questions. Huh? is, so the question is, how do you engage an audience that doesn't really want to be there? So that one's not so much a research talk, but there are talks where that kind of thing happens. What I try to do is try to find some way at the beginning to connect with the audience. I mean, really connect with them, kind of know, okay, and you got to give them a motivation so why they should care, or at least make it a curiosity that kind of gets them wondering why they're there. I think you have to do that. I mean, I do a lot of guest lectures. I do it on writing, and I know when I walk in they don't care, but I got to make them care somehow. Good question. How are we doing? Still doing okay? Still doing okay. Okay. All right, we're going to keep going. Actually, this is my favorite part. These are kind of greatest hits slides. Almost all of them are by graduate students, and they're kind of ones where, wow, I saw them and it was like, what is a completely different way to communicate some information. So the first one's kind of simple, but this one comes from Army Research Lab. I mean, one of their studies is just the effects of explosives, such as terrorist explosives, and how, I mean, the goal of the work is how you could reduce maybe the number of people who are injured in a terrorist explosion. And so one thing that it was a big takeaway, and to me this is why I really like this slide, is that a big takeaway of the work is that with some types of building materials, the fragments actually in an explosion, they move ahead of the blast wave, and they become the biggest cause of injuries for an audience. And so I really like the headline, and then I don't know where they found this particular photograph, but this is a photograph was in their kind of stock or something that somebody had taken. I'm sure that they didn't just put two people out there. We really want this photograph here. I'm sure that this was something that was genuine, but I thought that was pretty cool. Now, one thing that TED Artist will do is so the thing I didn't tell you is these three principles that I talked about were ones that kind of evolved on our own when we were developing this assertion evidence approach for scientists and engineers. And we kind of looked up and we realized that they're the exact, I mean, TED Talks have the exact same principles. I mean, TED Talks are geared toward, really wide audiences, whereas assertion evidence is geared much more toward more technical audiences. But I thought it was interesting we shared those principles. But one thing that TED Artist will do, and so I pay a lot of attention to TED Talks because their artists do some really wonderful things, but they do something where if they have a photograph that's kind of supporting whatever their message is, they will let it bleed the screen, or they'll try that. And that can be real powerful. And I thought in this particular case, that was a good example. This next one, a lot of times we're trying to motivate our audience. This was one by a civil engineer, Brittany Pavelko. And essentially in her project, she was trying to motivate the audience that there needs to be a design change to this Chesapeake Bay Bridge. And anybody who's ever crossed the Chesapeake Bay Bridge probably realizes there needs to be a design change. But she's trying to talk to audiences who maybe are not so familiar with it. And one of the arguments she was trying to make is that traffic has increased dramatically since the Chesapeake Bay Bridge was built. So it was built in 1952, and according to the Maryland Transportation Authority, 1.1 million vehicles crossed the bridge. So here's a point for you. You know, when you use somebody else's data or somebody else's graph in a research talk, you have to give them credit. I mean, this is like, oh my gosh, if there was, 10 sins, 10 commandments, don't use somebody else's work and not credit them. But how do you do that? And a kind of a nice way here is it doesn't have to be big type. This is only 14-point type, but kind of an author year with brackets is a nice way to do it. And then in the notes page, put the full citation. I see people put the full citation in like microscopic type on slides, and then it just goes across. Nobody can read it, but I would argue more for something like that. But anyway, that was used there. So, 1952, 1.1 million vehicles went across the bridge. Let's jump 10 years to 1961. We had an increase, not a huge increase, but a significant increase, 1.5 million vehicles. But let's jump to 2007. So this is 25 years after the bridge was built. In 2007, 27 million vehicles crossed the Chesapeake Bay Bridge. I think this slide is cool. And in a sense, it's a bar graph. But it's a bar graph in which she told it as a story. And I thought that was really nice. I think the black works well here, because if you did it with white, there's just be too much white space, but the black kind of worked really nicely there. Anyway, I like that. I like that for the dramatic effect, and I also like how the scene itself became a story. Oh, this one's another one. This is Barbara Beacons from the U.S. Geological Survey. She's kind of a well-known scientist, but she's adopted assertion evidence for her talks. And this was one from a lecture that she gave around the country. And the point I'd just like to make with it is that she's got a sophisticated assertion. I mean, a specific assertion. And then she just kind of drew some things, just using PowerPoint's kind of drawing tools. But it was something where she could show really some important scientific information in terms of how these oil spills, how they infiltrate into the soil, and how you get these different bands, that are formed with time. I just thought that was really nice, and I saw her spend, a good minute and a half explaining that visual evidence. This one's pretty cool. This one comes out of Texas Instruments. And here, again, visual evidence that is rich. It looks more fancy, looks more fancy than it is. But essentially what they have here is that they've got these packages for these semiconductors, and that they've changed over time. And so what I like how we get time, we get size, and then we get some information where they made a dramatic design change. We get a lot of information. It's visually rich, is what it is. It's not necessarily complicated, but it's visually engaging. This one's pretty cool. This one comes from Jimmy Weber, the forestry student. So some of you are saying, I don't have these photographs and stuff like that. But there are a lot of things that you can do when you just try to think visually. So he did have some photographs, but on this particular scene, he's talking about these measurements that he made of streams in the northeastern part of the United States. So he looked at 53 streams that are in parks in the northeastern part of the United States. And the research question is, how polluted are these streams? And so what does he mean by polluted? And so on this slide, he kind of defines what he means by polluted. He's got these 6 variables. He's got the pH, he's got the chlorine level, the chloride level, the sulfate level, total phosphorus, total nitrogen, and then this average habitat score. So if you had like a liter of water, how many tadpoles and fish would be in that little liter? So that's what he has. And so what does he mean by polluted? So he's got, like a lot of you, he's got a control. So in his case, he's got 12 streams that are kind of isolated from man, about as clean as you can get. So there, ideally, the 53 streams would fall into that green band, into the control band or the reference band. And at this point in the talk, he actually gave a couple of the key results, and I thought that was just interesting. But he said a big finding of my work is that this sulfate level is actually outside that reference band. It's not in a band where things are being negatively affected, but it's definitely outside the green band. And then the chloride level, that is distinctly in the band where now fish and plants are being negatively affected. So kind of what he's done here is, in a way, he's created a table, but it's a table that changes during his talk. And so in a way, he's telling the story of this scene. I just think that's really cool. One more slide I'll show you. You know, a lot of times people will show these. So think about your PhD dissertation or your master's defense. They'll show these huge tables at the end that nobody can read. And so he, in doing his PhD dissertation, which, by the way, the faculty said was the best PhD dissertation defense they'd ever seen, okay, in forestry. And a couple of faculty members said, actually, this is the best talk we've ever seen in our department. But he had a really big table in his dissertation, but he realized if I showed that table, people, they wouldn't be able to read anything. So what he did is he took the most important cells and he's going to kind of bring them in. So you talked about animation. This, I think, is a really good example of animation. So and he anchored it with an image that he'd shown earlier. So they had parks from different parts of the Northeast. And one of the parks were the West Virginia parks. And the big takeaway, 48%, if you look at all 6 variables, 48% are considered fair. And what causes the most problems? In West Virginia, it's sulfate. If you go to western Pennsylvania, 75% are fair. What causes the most problems? Well, it's chloride. And if you go to Delaware River parks, 79% are fair. What causes the most problems? Well, again, it's this chloride. And so if you look at the overall takeaway, 53 streams, 13 streams would be considered in that reference band when you look at all 6 variables. And then 35 would be in the fair, and 5 are definitely, look at all 6, they're impaired. I just thought that was a cool way to do that. There are things you can do with the headline. So sometimes the audience isn't ready for the takeaway. One thing you can do is rather than at the start of the scene showing the takeaway, you might start with your transition question going in. Now, I'm going to show the takeaway before this scene's over. A lot of people say, I put questions at the top. And then what I say is, okay, that's your transition into the scene, but the audience came for the money. Okay, the money's the takeaway. And so, but I could see sometimes starting with that question, particularly on a longer scene, and then animating in the takeaway. So the big one here is, so a lot of you have graphs, and so this is a graph, and in mechanical engineering and thermal fluids, a lot of times they kind of graph this F, which is friction factor, and then on the x-axis this Reynolds number. And what they wanted to know is what happens in this channel, it's kind of a square channel, if we roughen up the surfaces. What happens to the friction factor? Does it increase? Does it decrease? Does it stay the same? And they had to, of course, you have to have something to compare it to. And so you go back to Blasius in 1894, had found, had kind of hypothesized here would be the relationship of friction factor to Reynolds number if in a perfectly smooth pipe. And so they did their measurements in a smooth pipe, and you can see within the experimental error, they kind of follow Blasius's curve. So that's that first part. So now they're going to roughen things up, and they're going to roughen things up in 3 different ways. And the roughness kind of depends on how high the bumps and things become. I think they used pins in this case. And so here, it could be 1% of the H, which is the height of the channel, 1.7% and 2.2%. And then, so when we plot these, here's what we find. We find that in all the cases, it increased friction factor, which was something that they wanted. So that's what they ended up doing here with the headline. They could have done other things with the headline too. One is that actually, once you get to 1.7%, it looks as if even though you might increase it, you don't still get any increase in the friction factor. But I liked how they brought that headline in. Here's another way you might do it. You might only show part of the headline and then show the other part when you're ready. So this is some of the work of Stephanie Velagal in civil engineering. And so she's been looking at this moringa seed as a way to purify water. Because in a lot of parts of the world, people can't get access to clean water. But for some reason, a lot of those parts, this moringa tree grows. And so the moringa seed has this really interesting characteristic that if you put it into water, even really dirty water will become clean. The problem is that even though that works, if that water, you really can't store it, because what happens is that over time, it becomes dirty again. And the reason for that is that over time, bacteria continues to grow. And so then now you've got, what are you going to do? And that's what her research works on. But I thought that was a nice way to kind of hide a message until you were ready to give that part of the message. I thought that was pretty cool. This one is just some of Michelle Kay's. You can kind of look at hers. I think a lot of you have, again, you don't really have images, but you've got maybe flow charts. And I think the thing here that I like is when she walks through it, she kind of brings in images or brings in mathematics to kind of explain things. So see how some parts are gray, and then she'll explain those parts, and then she'll highlight them. And so again, I think this is a cool way to do animation. And then, she can kind of bring in the mathematics and then, kind of get the focus. And you can see her give that one. So she's one of the grad presentations, example presentations, model presentations on assertionevidence.com. This is another one. This was from Shanghai Jiaotong. They're trying to, like when you've got a machine that's cutting at an angle, how close does it really come to making a true, 90-degree cut? Because what's doing the cutting is circular, and so it's not quite perfect. But, to do this calculation, you have to make some assumptions. So that's what they did here, is they made this assumption that these two segments on that angle were the same. And if you make those, then these equations apply. I just thought that was just a nice way to bring in equations for you. So those were some kind of my greatest hits. I was going to have you do like another exercise, but I think what I might do is just kind of open the floor for questions, and then we'll take a couple of questions, and then I'd like to show you a title slide, and then I'd like to show you a conclusion slide. Anybody have any questions at this point? Did you like those? Man, I thought those, I don't know. I really like those. Yes, sir. Oh, okay, so that's a good, yeah, why the message at the top? I'll tell you, it doesn't have to be at the top, but a lot of rooms that, people are in, if you put it at the bottom, a lot of people who are sitting in the second or third row can't read it. And that's why I've gone with the top. I thought also Richard Mayer, the guy I mentioned who does all that work on that multimedia learning, he attended one of my workshops, and he thought from his perspective, at the top is actually the best position for it, because the audience could go up, grab the safety rope. But I will tell you, so TED Talks, they move it around, because they don't, they're the way they're filmed and things like that. You don't have necessarily people, so they may put them in different parts, and they may put them artistically in different places on a screen. But to me, that's kind of hard. The top is kind of like it works. People can read it. Yeah, it's a good question. Yes, sir. Well, I have some visual evidence that shows at the beginning of every scene. Okay, but I typically will animate in more complicated aspects of the visual evidence. But there will always be some visual evidence when the slide first appears. Yeah. But I could see you, again, kind of similar to what I did with the question, I could see you just showing the visual evidence and then animating in the headline when it was ready. I'd probably, yeah, you could do that with a black background or a white background. I could definitely see that.
I have a question. If I have results with a lot of variables that one slide can't, is not enough, I can't put all the results, all the variables into one slide. How to deal with that?
Yeah, so here, it may be, I might have to think about how much my audience is going to be able to understand. Because if I've got 20 variables or something like that, they're not going to be able to remember all 20. I'll read them. So maybe though they could look through them if it were in the paper. So sometimes what I do is I show examples. These are 3 or 4 curves. Let's say with curves. Yeah. So you may have had 20, but you're only going to show 3 or 4 to kind of show a result. So sometimes I don't show everything in a presentation that I show in a paper. Yeah. Michelle, do you have a question? So is this on a single scene or in the whole presentation? Yeah, so I'll show a mapping slide here in a little bit. I'll do a mapping. If it's just methods, results, discussion, that you could just say that in your speech. But if it is more sophisticated, you've got theory, then maybe you've got a whole experiment where you did methods, results, discussion. Then you've got maybe consequences. I will show those 3 on a slide, but I'll have an image that anchors each of them. And that image will be on the first scene of that section. Yeah. Yeah, that's good.
So I'm very persuaded by the people of the organized presentation around that. And I thought back from my own presentation, and I realized probably the reason I'm hiding in the template or I'm hiding in the topic today is because I'm always presenting work in progress. But more often than not,
Yeah.
I don't have my conclusion, but the format of a takeaway or focus on the message is up. So how do you present works in progress if you don't necessarily know?
Well, I think I think what you might do is you might couch those assertions in, at this point, we think that, and you kind of give that as a takeaway, and you kind of state things up front. But I mean, it's really important that you distinguish between what you know well and what you suspect. So you want to use those words in your speech, and sometimes it could be, we suspect that, might be the way that the sentence begins. Yeah. So the beginning, the beginning is really important, and here's how a lot of people begin. They'll begin kind of with a scene that looks like that, and somebody will say, my name's Stuart Apple, and I'm working with Carrie Cho and Dale Gray. We're the environmental engineering department at such and such a university, and what we're studying is atmospheric mercury depletion events in polar regions that are in Arctic Spring. And then that scene will be gone, okay? And that's kind of a problem, because from the audience's perspective, they didn't really get it, okay? They don't feel comfortable with the title yet, and the train seems as if it's left the station. So a lot of people rush through that scene. Somebody who didn't rush through the beginnings of his talks was Einstein. And that was something that a lot of people noted, that, whereas a lot of people just go really fast through the beginning, he would be real patient. He'd spend more time on the beginning. Because for him, it was important that everybody was acclimated. Now, why do so many people begin this way? Well, you kind of know the answer. It's what PowerPoint kind of tells you to do, all right? Leads you to do. But we got to remember, 1986, Gaskins and Austin, they were just doing the best they could, and they didn't really have many cards to play. They just, we got to have a title slide. Maybe here's how we would arrange it. And so then they came up with that, and we've been living with that ever since. But we can do better. So I want to show you what a graduate student in chemistry at the University of Oslo did. So she was going to give her first conference presentation, and she wasn't giving it in her native tongue of Norwegian. She was giving it in English. She was actually going to Portland, Oregon. And she did a smart thing. She asked her advisor, she said, how many people are going to be in the room? And her advisor said, we'll have about 50. She said, okay. How many of them know what an atmospheric mercury depletion event is? And her advisor said, I'd say 5. You're 1. I'm 2. Torun Berg, our colleague, 3. So maybe 2 others. She goes, okay, got it. So here's how she started that presentation. Hello, my name is Katrina Asmo, and I'm working with Torun Berg at the Norwegian Institute of Air Research. I'm also working with Professor Greta Wibito from the Department of Chemistry at the University of Oslo. And what we're trying to understand is what happens to mercury when it depletes or falls out of the atmosphere. Now, some of you may not realize that in the atmosphere, in this room right here, there's a certain amount of mercury. It's not much. It's about 0.2 nanograms per liter. And in this room, it stays in the atmosphere. Even when we breathe it in, we breathe it out, it just stays in the gaseous form. But for some reason, and people aren't exactly sure why, but in the polar regions of the world, such as this beautiful Null-Aalesund region here of Norway, you have these events where that level of mercury will drop to 0 in the atmosphere. And these events, they've got a fancy name. It's called atmospheric mercury depletion events. And so what our research question was, is what happens to that mercury? Where does it go? Now, many environmentalists assume that it goes into the surface snow. And that, as you might imagine, is a problem. It's certainly a problem for mammals, for Arctic foxes, for polar bears, for stray Norwegians wandering through that particular area. that because I think almost all of you know that mercury is incredibly toxic. It affects the neurosystems of mammals. And so what we did is we went to this beautiful region, and you may not be able to see it, but in this corner there's a cabin. And we stayed here for 2 months during the springtime because these events, they seem to happen more in the spring. And what we did is we made simultaneous measurements between for the mercury in the atmosphere as well as mercury in the surface snow to see if there was a correlation when one of those events happened, that when that level of mercury in the atmosphere dropped to 0, does it increase in the surface snow? Wow. I remember being in the University of Oslo's chemistry department and hearing her practice this talk and thinking to myself, man, I am lucky. I mean, I'm not an environmental scientist or anything, but I'm thinking, I'm going to learn something in this talk. I've already learned something. I just see that the beginning of a talk is this incredible opportunity for you to give the audience some valuable information. But if nothing else, make sure that they are comfortable with that title before you leave it. Now, she gave essentially her whole introduction. She gave her credibility statement. She gave the motivation for the research. She gave background information, and she talked about the scope of her research. I mean, it gave the research question. She gave the introduction. But what I liked is I liked the pace of it. She didn't have as many scenes as a lot of people do, but man, the scenes counted. So I'd say that's a good beginning. And then in terms of an ending, don't do what a lot of people do. They'll have like this slide. And you think about it, this is the transition from your part of the talk to where now the audience is going to ask questions. And when you ask for questions in a research talk, you want hands to go up. What on the screen helps the audience formulate a question? Absolutely nothing. It's a 0 for the audience. I'd say it's less than 0 in terms of a slide. We can do better than that. So let me show you what Danielle Lesso did. So here's her last slide. So she restates the main takeaway, that miscanthus could be a possible biofuel source for the Northeast. And then she goes over her arguments. First, it's got a cold tolerance down to 6 degrees Celsius, which is important for the climate. Second, the root depth is more than 2 meters, which means that even in the hilly slopes of the Northeast, it's much less susceptible to erosion. And then the third one is, and there's the big takeaway, I mean, its energy ratio is 6 to 1. The amount of energy you put into growing miscanthus, you get 6 times that when you combust it. And that's 4 times higher than corn. And then at this point, she kind of says her last statement and she pauses. And in an ideal world, everybody would erupt in clapping. But, well, people are nervous about that. They've clapped too early at a classical music concert, and so they're shy. And so, but you could get them to clap by saying 2 words. Thank you. Yeah. You say thank you. You pause, you say thank you. People who have maybe been asleep, they'll wake up clapping. Okay, it's just a kind of a natural thing that people have. And then when that clapping dies down, that's when you want to ask for questions. If you want to animate in this word, that's fine. But that's when you want to ask for questions. But now the audience has got a scaffold for them to build a question on. Now, a lot of times they will want to jump. Oh, could you go back to your graph on slide 6? You can jump to slide 6 without having to scroll through all the slides. And the animations, that's a disadvantage. But you can do that by typing in, does anybody know, at the keyboard? 6, that's right. Type in 6 and then hit enter. That will jump you there. So a good thing for you to do is, if you've got backup slides, know the number that you want to jump to. And also, if you've got to, you've gone to slide 6, know what your last slide is so you could come back to that one if you needed to. Very good. Very good. Well, that's great. I think we're at 3:30. I hope that you got something out of it. I got to tell you, Jimmy Weber sat in on this exact same workshop, 2 hours, and he ran with it. And he not only, gave this incredible PhD defense that people still talk about, but he also won Best Presentation at the next conference that he went to. I think for you as a scientist or an engineer, I would say that you should think about experimenting with it. I think it's a good, it's an interesting approach to experiment with. And just the first one alone, where you come up with the messages, that will make you a more focused presenter. Thank you. I will hang around and answer questions. Laylee wanted you to know that there's a survey here to do.